Hey guys, Jay Kelly back with more work on the Kearney Trekker knee crank. Look, I wanted to apologize up front for the shaky video. I got a new camera. As everybody knows, I'm now doing HD. For some reason, I think it might have to do with image stabilization. The old camera had no problems using the same exact mounts that I'm using now, and the new camera shakes like a dog. I don't know if that's because it's 1080p or if it's because the new camera has image stabilization, which I have turned off. So hopefully this video will show that we've made some improvements in that. Anyway, so the nose of the crank is done, or is mostly done. But in order to proceed, we've got to do the actual long crank portion. And I have laid out on here the crank portion of the assembly using good old-fashioned Dicam and Scribe. So we've got this laid out here. I'll bring the camera over in a second and show it to you, get you up close. Before we start carving on this thing, I'm going to go ahead and drill the hole for this, the crank handle, and then I'm going to drill and bore the hole to fit over the nose that actually hooks into the mill, while this is still rectangular and easy to hold. Once those two things are done, I'm going to bandsaw out as close as I can, bandsaw this out, and then we're going to clean the edges up all around. Then we will put the whole assembly into the spacer on the mill, and we'll drill for those round keys that we're going to try. I've never used before, but we're going to try with this assembly. So let me get the camera over and show you the layout. Again, I've increased the center to center distance 2 inches to 12 inches instead of 10. And I think it should be, this is 1/2 inch stock. I think it should be plenty stout for this application with 1/2 inch material. So we'll find out, of course. So let me get the camera and we'll check this out. All right, here's the here it is right here. Small end, right? That's a 7/16 hole for the handle that presses in there, and then tapering back up to I've got this set up for a 5/8 inch hole. I'm trying to get the glare off of that. There we go. I'm gonna drill a 5/8 inch hole here, and then I'm gonna put the boring bar on it and expand it out until the boring head on it, and expand it out until we hit the dimension we need to fit the crank nose. Then I've got one edge running along this long edge, so it's straight. Then we're going to bandsaw out this taper. That ought to be fun. And it's about now that I really wish I had a belt grinder. And then we're going to start cleaning this up, cleaning the long edges up, and cleaning all this up with the side grinder just to get it ready to go. So anyway, let's move over to the mill. Like I said, the first thing we're going to do is drill these 2 holes and bore this hole while the stock is still rectangular and easy to hold. So let's go over and do that. All right, we're over at the mill. Got a little, I got one of my little number 7 spotters in there, and I'm just lining this up by eye. This is as good as it needs to be for this purpose. Neither the center length has to be exactly on some number, nor does the axis have to be absolutely perfect to the thousandth of an inch. So this really will be good enough. One of my favorite sayings is, Don't let perfection be the enemy of good enough. So let's fire it up here. Going the wrong way. Pretty darn close. Close enough for the purposes of this. Now let's get a let's get a 7/16 drill bit in the hole here. All right, the I've measured the handle, the rotating handle, several times. Excuse me for giving you the view of my hand, and it measures about 4/3/6. So we're going to drill this 7/16. Will give us. I measured this particular bit here, and this particular bit measures about 4/33. So we're going to give this a run through here, and hopefully come up with a nice firm, not really a press fit, but like a nice slip fit that we can Loctite and make permanent. Okay, I still think I'm getting some shake in there, so I think it's the either the holder or the camera that's giving me the shake. So anyway, we will review this here shortly. I'll review this before I put the video up, obviously, to learn if the disabling the image stabilization has had any positive effect. Alright, let's see. Yeah, that's going to give us a nice press fit. So that's that is just about perfect. That'll give us a nice firm fit, not too bad, and allow me to get that in there nicely. This thing's rather a booger to work with. If anybody has any suggestions, this shaft rotates. There's really no way to hold this thing. To thread it, just, you know, it's kind of a difficult. So press fit was really all I could see as the proper way to mount this thing. So now I'm going to swap the workpiece around, and we're going to drill and bore out the big end to go on the nose there. Again, just gonna eyeball this stuff up, because that is good enough for this application. Let's see here. Yep, that's pretty good. All right, we're going to go ahead and put them mark on this, and then I'm gonna lock down my X and Y, just make sure I don't inadvertently hit a handle. And then we'll drill it. All right, we got a 5/8 inch bit in the chuck here. We're going to go ahead and just punch through with 5/8. That'll give us a good starting point to start with the boring to fit the nose there. Got it in back gear. Alright, cat's talking to me. Got the 5/8 inch hole through there. Let's get the boring head mounted up and let's expand that on out. Alright, that's made a quick executive decision. Before I slap the boring head in there, I've got to go out to 1 1/4 plus a little, so instead of starting out at 5/8, I've stuck a 1 inch annular cutter in here, and we're going to go ahead and chew that on down, go ahead and expand that hole out a good bit. And I'm doing this a little differently than I normally do. I normally use a holder, but I've watched Tom Lipton use these cutters successfully in collets a number of times. So if Tom feels comfortable doing it that way, I feel comfortable doing it that way. So we're going to go ahead and give this a pass through here. Getting a little bit hairy there. It's actually reaching out far enough to grab the base of the camera, and we don't need that. The only downside I can find to annular cutters is their ability to produce unbelievable chips or mess. So anyway, let's go ahead and finish that up. There we go. I will say that when you're using these with aluminum, be very conscious of chip packing. You can pack the flutes. I packed one of these so bad one time that I had to soak it in muriatic acid to basically eat the aluminum off of it. So, but I mean, these things give a fabulous finish, and there's the plug, a little piece that got cut out of the middle. So we're much farther along towards our dimension. Now we'll put in the boring head and go from there. Alright, we just took our first cut with the boring head. I'll zoom out here and give you a little better shot of the setup. We've got a 3-inch boring head in the machine there, in the spindle. Got some gunk on my lens, there we go. And got a little 5/8 inch boring bar with a 1/4 inch high-speed steel cutting edge, which gives us a really nice smooth finish here in this material. I like high-speed steel in the boring head because you don't have to run it so fast. It's not like carbide, so it gives you a little more forgiveness when you're cutting, especially with unknown materials. So anyway, I'm going to get a measurement, and then we're going to measure on out. We're going to work up towards our OD. Alright, I went and took a 0 on my OD and then got a measurement here with my ID, and it's showing that I'm still 142, 143 small. So we're going to dial some out and take another cut. Okay, we were at 143. We're now at 115. So I'm going to be at this for a little bit. Let me get back with you when I get close. Alright, well, we've taken a couple of cuts. Got down, and my measuring instruments are telling me I'm 24 to 30, 25 to 30 thou undersized. Alright, let's dial in 10. We're going to go 15. Firm that up. Don't spare the lube. I'm right at the changeover on my little bore gauges here, so I'm right at this step where you go from one to the other. And I'll be honest, my larger, these are cheap. I need better ones. And the next size up is really bad. It won't lock hardly, so. It's telling me now I am 11 undersized, 10 or 11. So that was about, we took what, 15 off of there, so that puts us at about 26, right in the range. I'm just going to shoot and just take that 10 off, and we'll go from there. For those that are interested, this is an old Bridgeport boring head, actual Bridgeport brand. And takes a 5/8 inch bar. I don't know how old it is. I've had it for quite a while. It's gunmetal blue, which is kind of nice, you know, if you're a firearm person. All right, let's take one more cut. That ought to have us pretty close right there. Try for one more number here. Let's see what we got. It's telling me I'm 1 or 2. So I'm going to drop the knee down here and we're going to try our piece in there. Let's see. You know, I bet you if I take a little emery cloth to that, I can make it fit. Well, can't get it in there. I deburred that edge. Still doesn't fit. So I'm going to crank the knee back up and take a spring cut. It's about now. I wish I had a power feed on the Z. Don't forget to swap up hands and give your left arm a workout. Oh my goodness. All right, let's take a little spring cut. Let's check out our cutting edge here. Feels plenty sharp. All right. Oh, I wonder what that noise is. Oh, my lube pump. You don't get this very often. The alarm on my auto lubrication pump just went off, so let's take care of that real quick. Alright, that happens once a year. Let's take another cut. We're going to take a power feed cut. Alright, let's measure it again. Alright, I measured again, and this time it's saying we're size on size. I'm going to crank the knee down here again. And we'll do a little test fit. That is perfect. I'll take that right there. It's a nice slip fit. Alright, let's get this broken down here. Alright, we got our hole drilled, we got our part out here, we got a nice fit. Very firm. I just want to give a little view of the bit that I ground, that's ground for that boring bar. So it sits in the end of the boring bar at a 45-degree angle. So we have a flat here, and then a flat on the end, And then there's relief here and here, right? So if you look at the end of that, you can see the relief on the back edge. And if you look this way, well, kind of this way, you can see the relief on this edge here. So it's just flat. It's just flat on the face. There's no chip breaker. I do have this this flat here on this end is important if you don't want to break a lot of tips. If you grind this to a fine point, you're going to chip that a lot. So you can tell where the cutting was taking place right here on the end. You can tell where that's happening. So anyway, that's the cutting bit that we use to cut that. It's just this is a piece of 1/4 inch Supermax high-speed steel. I believe this is available from McMaster-Carr. So anyway, there you go. Hey guys, so I was getting ready. I had this all laid out, the handle, crank handle. I had it all laid out. Was getting ready to cut it, and I said, you know what? I want to get that funky scale off of there, and there is no tool on earth better at removing funky scale than a metal shaper. And then I also remembered the video I did a while back on grinding a shearing tool. A gentleman by the name of Aardvark1 had provided some feedback on how I might make my shearing tool better. So I've made some changes to the cutter, which you can see up in there. I will provide you with some before and after pictures of the cutter and then the changes that I made to it, and then we're going to see how it's going to perform right here. So there you go. You can see the changes. Reduced the radius on the bottom, left pretty much everything else the same. It's nice and sharp. We're set up here with a nice feed, like a 40 thousandths feed. We're only really taking a very small cut. So we're going to go ahead and we're going to trim all this scale off of this piece here. Alright, so we just finished making that pass. Didn't take very long because, like I said, we're taking a 40 thousandths cut. You can still see obviously the two holes, which will help me lay out the handle back where I can do the bandsaw cut. Let me get a brush and clean that off. Here's my little chip catcher. I used to have a better version of this made out of metal, and I hope I didn't throw it away. Anyway, let's take a look here. So this is very nice finish. It looks pretty good. It'll clean up nice. And got rid of that scale, so we're going to flip it over and make another pass. I think I need a little less radius. So we'll try some more changes. Experimentation is what it's all about. Okay guys, so we got the part descaled here, you know, shaped off both sides. Video's getting a little long, so we're gonna move this one to a 3-parter. Still having vibration issues, so ordered a freestanding stand, not a tripod, but a freestanding stand to use with the camera so that it won't be attached to the machine. We're just gonna have to do away with the kind of the convenience mounting. Really didn't want to do that because you know, not wanting to have to walk around and move around, something like a tripod or some sort of independent mount. But looks like that's what we're going to have to do because the this camera just seems to be a lot more susceptible to vibration than my old 640 by 480 version. Anyway, we're going to finish this up quickly because I still need to get my machine back in action. And so look for part 3 here real soon. And in the meantime, be safe in the shop.